All right, I think we'll just get started here. So, welcome everybody to AI training number two. I don't know if you guys were all here in AI training number one, but just as a quick reminder of what AI training is, it's this workshop that we kind of run with the AI Club or the AI Research Club. And basically, the idea is to introduce you guys to these topics and concepts within AI and machine learning. And today we're going to be talking about data science and everything that has to do with that. And I'm not sure if a lot of you guys um, are signed up for the Datathon, which has a lot of people signed up for it. But if you have, this should be a really, really good introduction for what you're going to be doing day of and how to prepare for that, basically. Because I know the Datathon is new to a lot of people, and like this whole topic of AI and machine learning is new to a lot of people. So. Without further ado, I think we can get started. This is Data Science 101. I am your Vice President, Shaun, and let's just take it away. So today's goal, we have two goals for today. The first one, I would say, is to tell you as much as I can about data science in an hour. I'm really going to try to keep it within that hour time period, just to respect your guys' time. But if we go over, I might go a little bit over. We do have a lot to cover today. But if you guys have heard the saying, drinking out of a fire hose, I'm just basically gonna just throw all this information at you guys, and you guys just take in as much as you can. I'm not sure the experience levels here, but if you're new, this is probably gonna be a lot, and I expect it to be a lot, and that's okay. That's why this recording is gonna be posted, and if you want to look back, but everyone should learn something new coming out of this. And the second goal is to tell you how to get started. Um, a lot of people are wondering how to prepare for the Datathon and basically how do I start building AI applications. In our last AI training, we just kind of went over the concepts of machine learning, but I didn't really give you guys guidance on how to or what to do with that or where to take it from there. So today we're gonna kind of go over that a little bit. But yeah, those are the goals. And this is the agenda for today. First, I'm going to do a quick introduction on data science, and then we're gonna go deep into the data science pipeline, which is kind of what this is all about. And then I'm going to talk about data science versus related fields, where we'll talk about like data engineers, data analysts, what they do in comparison to like data scientists. And then I'm going to talk a lot about how you guys can get started preparing for the Datathon or making your own data science projects, and then I'll just close it off. Okay, so I think we could just jump straight in. So what is data science? Data science is the process of taking noisy data and extracting knowledge slash insights that could lead to actions that a business or organization can use. Um, and that might just sound like a whole bunch of jargon, but basically, what I want you guys to take away from this is we're going to be taking a bunch of data. Doesn't matter if it's like all like together neatly or nicely. We'll fix that later, but we're just gonna be taking a bunch of data, and then we're gonna try to learn as much from this data as we can, and then from what we learn from the data, we're gonna try to implement something based on what we're trying to accomplish. Okay, that's kind of like the whole idea of data science is gathering insights from data and using or applying them. And then I have this Venn diagram over here on the right side. This is a popular one I always see about data science that I agree with and I like a lot. As you can see, we have the three bubbles: computer science, or I could use my mouse, computer science, mathematics and statistics, and like domain knowledge, which is basically your knowledge on like whatever area you're, interested in. And so the combination of computer science and math is like machine learning. But the combination of computer science and software development, or sorry, computer science and like the domain is like software development. And if you're like really good at math and like you know a lot about a certain area, you're probably going to be doing research in that area. And like all three, I would say, is what kind of data science is. And we'll kind of talk more about that as we go through today, but that should give you a general idea of what it is. And for this next slide, just a quick example um, of what an application for data science straight out the bat from the definition I just gave you guys is like a fraud detection in like banking or finance. So say we want to make a model or we want to crack down on fraud or like maybe people's credit cards getting stolen, something like that in banking and finance. So how would that happen from a data science perspective? So first, we'd want to gather a bunch of customer transaction and behavioral data, basically the data of like, their buying habits, stuff like that. and a bunch of that data though, as many customer transactions as we can find. And then we're gonna try to extract indicators from that data that of like outlying data. And basically this outlying data could represent like the fraud because, fraud isn't gonna be as conspicuous as like um no like everything else. It's gonna be kind of just hidden or not hidden. It's gonna be kind of obvious, like like buying something for $500 at 3 p.m. versus $10,000 at 3 a.m. It's kind of obvious when it's fraud, and there's other ways to detect fraud that aren't like very straightforward like that, and so this is what the model is gonna try to come in and do and try to figure that out for us. And then after we extract indicators of outlying data that could be fraud, finally we're going to create a system that catches fraud, right? So, for example, a model that sets up alerts or maybe cancels the transactions if it thinks it's fraud. Okay. And so now that was just like a quick overview on what data science is and a quick example. And if you didn't really get that, that's fine because now we're just going to jump straight into the data science pipeline. This is going to be like the main topic for today. We're going to spend the most of the time talking about this data science pipeline, and I really want you guys to try to understand this, so please do. So, first, step one of the data science pipeline is going to be the problem definition, understanding business problems and then formulating them as data problems, right? And so, what's an example of that? We could change the question of how do we catch credit card fraud to how can we use data to determine fraud through user transactions and behaviors, right? So, the first step is to try to wrap your mind around how data can fix a certain type of problem. All right. And step number two is now collecting or mining the data, which is just getting as much data as you can from different sources, whether that be APIs, web scraping, databases, open data sets, etc. Wherever you can get the data to try to help you with this problem, you get it. And an example of that in our scenario would be gathering transaction history from a bunch of different users, right? So these are the first two steps. Next step, I kind of have a 2.5 here, and this is going to be the initial exploratory data analysis, which is what EDA stands for. I'm just going to be saying EDA from now on. So just remember that means exploratory data analysis. And this is probably a new term to a lot of you guys. This was a new term to me when I just started learning about data science, but basically, um, it's kind of what it sounds like. An exploratory data analysis is you just taking the data and exploring it and trying to gather as much insights and intuition you can from the data that you see. So for this initial EDA, this is where you're going to explore the data you have and then try to understand the data and identify problems within the data, right? And we're going to talk about what these problems are in a second. But basically, the whole point of exploring the data right now is to try to help you prepare for this next step that we're going to talk about. But an example would be understand your given data set structure, right? Which an example of fraud and customer transactions, this data set could consist of the number of transactions, the different features from each transaction, such as money spent, timestamps, where the transaction happened, etc. And then try to gather all the fraudulent transactions, right? I try to understand which ones are fraudulent, which ones are not. And this identifying um, problems is what leads us to the next step. And I would say the most important step in the data science pipeline or life cycle. I'm just going to call it pipeline for today, but it's also called life cycle or process. Um, is data cleaning and pre-processing. And I talked about this a little bit in our machine learning 101 workshop, but basically, this is the process of detecting, correcting, and handling errors in raw data to make sure it's suitable for analysis or your machine learning model. And as I say right here, this is one of the most time consuming but important, and I think it's the number one important step, but one of the most important steps in the data science pipeline. And so we're going to be going over a bunch of different techniques and what this means, and these techniques should show you guys what this really means when we're cleaning or pre-processing the data. The first one and probably one of the most popular ones, and it's probably because it's the most intuitive and people understand it the most, is handling missing data, right? So there's going to be some values in your data set where maybe someone forgot to put in the value, or maybe it's like an unknown, right? Something like that. Or maybe it was like some error in data entry. Basically, we have to handle this missing data because you can't just put missing data into a machine learning model. It's not going to know what to do. It's not going to know what to do once it gets to that value, right? So there's two main things we can do. First would be removing the rows with the missing data, right? If we think that the data is unimportant if it has a missing row or the certain like transaction is unimportant if it's missing certain data, we could just get rid of it. Or we could do something called imputing missing values using like the mean, median, or mode, or marking it explicitly. And imputing basically means in this context to insert mock data into that area, right? And so you'd probably want to use like the mean or the average of all the data points to insert into this missing value. But there's, there's scenarios where you'd want to use the median or the mode just as much. Or there's even other algorithms I won't get into today. But yeah. That's how you handle missing data. And so now another thing that we have to do is handle duplicate data, right? If there's multiple entries of the same type, we want to usually just drop the duplicates. A lot of the time, it's usually a mistake, because there's usually stuff in the database that should identify duplicates, and this is probably just a mistake that there are duplicates in the first place. So you want to usually drop those duplicates. And then we want to also handle inconsistent data by standardizing the formats. Like, for example, a good one that I have here is there's multiple ways to put the date down. And we want to just make sure that it's congruent throughout the whole data set. Because, again, once the machine learning model gets to a date and it looks completely different than another date, but they could mean the same thing, it's not going to know that. We're going to want to make it standardized. And this is another example here. Like Apple, the company, could either be like Apple Inc., Apple with all caps, right? And making sure that all of those values are just turned to Apple makes it a lot easier for us to understand the data. I think I'm gonna go a little bit quicker here too, because we have a lot to go through. So again, before I just really ramp things up right here, we're gonna go over a lot, and if there's anything that you don't know, it's okay. Um, and I would just try to take in what you can, okay? Because I'm realizing I'm kind of going a little too slow. Okay, so fourth thing, detecting outliers and anomalies. There's gonna be outliers in data and anomalies, things that basically are kind of standing out, and basically what this does when you feed it to a machine learning model. Or even like put it in like a some type of histogram or graph, is that this value is kind of skewing all of the relevant data, and usually outliers are something that we don't really want to account for if we want like a generalized data set. And so there's different methods to take care of this. Here I have a couple, and if these don't make any sense to you, you can look into them, or you'll probably learn them as you go. But we have the Z-score method. We have the IQR, which stands for the interquartile range method. We have domain knowledge. And an example I have here is if somebody's age is inputted as 500, that's not possible, right? It's just like common sense, kind of. And then after identifying these outliers, you can usually remove them, transform them, or like set a cap to them. Those are like the three most popular things that I know people do to outliers when you find them. And kind of continuing here, we're still on part three, is handling data scaling. So different features in your d data set might have different ranges. If not handled properly, they could negatively impact your model, right? Right. And if that doesn't really make sense, I have an example for you guys. So age ranges from, let's say, in our data set, age ranges from like 18 to 80 years old, but income in our data set ranges from 20K to 500K. Since income has a much larger range, what the model does initially or intuitively is it takes like these bigger values and applies more weight to them, thinking that they have more impact over like the overall outcome, even though maybe they have the same proportionate weight, right? And so there's a couple of things that we do about this. We either do something called min-max scaling, which is normalizing all values, which basically means you're putting all values between 0 and 1. Um, and this helps get that huge range down to like a uh, you know, compact amount. And then standardization is another one, which is basically normalization, but it's not really normalization actually. It's just turning all the data into their z-scores. And then this is the second time I've said z-score. If you don't know what a z-score is, And if you haven't taken like a intro to probability course, you'll learn about it. I would look into it, but basically it's a way that we could try to quantify what the data is um, in correlation to the data set. And so turning into z-scores makes the numbers a lot lower and a lot more digestible for the model. Or we could do something like log transformations if we see something is scaling it like exponentially when it shouldn't be. And so yeah. So this is the last thing I have, which is we're going to talk about a little bit more in a second too, but it's feature engineering, and this is this could be its whole other part of pre-processing. But basically, it's converting raw data into like meaningful inputs for your machine learning model, and like trying to get like a better understanding of your data. So some like techniques that I'm going to talk about in a second is basically just taking your existing data, your raw data, and turning it into something that could either be digested by the model or that might be important to the model. So for the first example here, I have something called one-hot encoding, and this is basically turning um, like strings and word data into numbers so the model can digest them. For example, here I have red, blue, green, and we're turning that into 0, 1, 2. Another thing that we have is binning. Maybe we don't need the excess like complexity of each age being different, so we could just put them into bins. That would be these groups where basically we include a certain amount of variables. You guys get what it is. Basically, an example would be age groups less than 18, 18 to 35, 35 to 50. Um, and then another pretty big thing with feature engineering, which probably takes a lot of domain knowledge and like some background knowledge, is feature extraction. Oh wait, no, sorry. That's the next thing. Feature extraction is just like extracting the day, month, year from a timestamp. Usually, all that's like time data, most popularly, is like all in one data point. And so, if we can get like the seconds, year, hour, month, day, and put them as all separate uh data, or like I'm just gonna call them features, that'd be a lot more useful for the machine learning model a lot of the time. And then finally, this is the one I'm talking about where this is going to take a lot of probably background knowledge, but basically it's creating original, impactful features based on the raw data you were given. Example I have here is if 95% of fraud transactions happen late at night, we might create like a night transaction feature, right? And these are like the features that are happening between a certain time period, and we track those as like a separate column in the data set. And we like maybe like the machine learning model will take those and understand that that is like really important in comparison to like maybe that data might be like undermined by the machine learning model since it's in this whole other pool of data, right? Maybe we want to extract it and turn it into a different feature. And so that's basically what this is. You make your own features within the data set, but with stuff that's already existing. Obviously, if you have data, you don't want to just add fake data to it a lot of the time. And so you want to use data that's already existing. But that's something that's, kind of hard to do if you don't know much about the topic you're talking about. But it is very powerful. All right. And so the next step of the data science pipeline, that was all step three, all pre-processing and cleaning. Now that we have cleaned the data, we can perform a deeper analysis. And this is going to be a detailed EDA. This step gains those important insights needed to better the machine learning model performance, right? So an example of a detailed EDA would be like visualizing distributions with histograms or density plots, checking feature correlations with heat maps, analyzing relationships with scatter plots, pair plots, and you could also feature engineer new variables after understanding the data. Like maybe when you first were pre-processing and cleaning, you didn't know that something would be so impactful, but then when you visualize it, you'd be like, wait, that's something that's actually it looks like it's correlating a lot with like fraud. Let me feature engineer something so that like I have like this better visualization of how that correlates with fraud, right? And so I have some examples down here. Here's some histograms, some scatter plots, and there's like a bunch of different ways to visualize your data. And so I just have like a little picture of that all down there. Now, step four, which is the machine learning development. Now that we've cleaned our data, we understand our data, we know what's kind of going on. Um, we can now choose the model based on our scenario. And I'm gonna be honest, this is the easiest part because you could really redo this over and over again, assuming that, your data set is in billions of values and you're not trying to train something that's going to take months. You could do a lot of trial and error here, right? And sorry, excuse me. I think like the biggest mistake that people in data science or when they're learning about machine learning is to jump kind of head first into machine learning development because you want to learn more about these models. You think they're really interesting. Um, I would say that's the number one mistake because the model it's the easiest part. It's the most fun part to me too. I won't lie. I like seeing like how models do against other models and like even the math behind some models. I'm like, wow, that's pretty fascinating. Like that it could predict stuff like that. But like I think it's important to understand the background and what you need to do to get to this point. So I just wanted to say that really quickly. But here I have for machine learning development, the first thing you have to do is to break your data up into different splits, right? So this is I'm not gonna spend too long on this, and you guys can look into it more yourselves. But basically, say you have this full complete data set with transactions labeled fraud and not fraud. Well, we're gonna want to break it up to where we have data that we're gonna be testing or training the model on, and then we have data that we're gonna be testing the model on at the end, right? Data that it hasn't seen yet, but we're holding till the end. And this validation set in the middle is kind of like a pseudo test set. But basically, what you do is you train your model, you test it on validation first, right? And then after you see what its percentage is on this validation, you do like your tweaking, and you basically keep on looking at the validation set as you're tweaking the model. And at the very end, this is where you introduce your test set. And then this test set will tell you how your model really does on completely unseen data. And so that's kind of like the idea behind train validation test. If you're kind of confused, just look into it a little bit more. But kind of what I was saying earlier, don't just try one model, train multiple and evaluate them. And evaluating is going to be the next thing that we talk about. But again, you're not really limiting yourself when you choose a model. So don't spend too much time choosing the perfect model for your scenario, right? You could always test multiple. And an example I have for machine learning development is going to be detecting fraudulent transactions. Since it's a classification task, I might choose like the random forest because it captures like these nonlinear relationships better. Or I might choose logistic regression and maybe use that as a baseline on what I can expect, just because it's just like a simpler model, right? And so that's an example of what kind of the thought process you'll have when choosing a model. But again, don't spend too much time on that. And the reason I say this is the easiest part too is if you see the code in the bottom left, this is all you need to do after you pre-process your data to train a model, modern day with Python libraries. It's literally three lines of code, and one of them is importing the library that you need. You literally just initialize the model, and then you fit it on your training data set and your Y, which is like your zeros and ones. And you guys will learn more about this, but basically the Y is like your labels, if it's gonna be fraud or not fraud, and the training is gonna be all the data set features. But you literally just fit it on there, and then boom, your model's done. Now you're ready to evaluate. So that's why I'm saying it's one of the easiest steps. Don't spend too much time on it. And here's again kind of what I have for a picture to visualize the train, validation, and test sets. Here we have training and testing, right? The holdout example is what it says here, which is I think a good way to put it. And if you want to use a validation set, which I recommend that you do, here's like a way to split it: train, validation, holdout sample, so you don't train it on that data, and then you test it at the very end. All right. So now we're on step number 5, which is model evaluation. Um, Using different metrics to evaluate your model, that's basically what model evaluation is. This is at this point you've cleaned your data, you've made your model. Now it's time to see if your model is actually good. So this is also definitely, I would say this is number 2 for most important steps. But it's also one of the most difficult because this is where you kind of need to understand how what your model is outputting in correlation to what the business problem is and that perspective on it and like how to better your model based on your evaluation. It's kind of like the hardest thing to do, but it's kind of just something that takes time and you'll understand like some patterns there as we go on. Um, but like I say, it needs a strong understanding of the data plus goal plus model to really master evaluating your model. And it's different for different tasks. All model evaluations aren't the same. And we're gonna go over a couple right here. So first, classification, and I'm really gonna try to zoom through this because I don't want to take too long trying to explain this. I think this one's an important one to explain though, so I might take a little bit longer than this one, but after this I'm gonna start really going. But for a classification task, right? The number one is accuracy. We're gonna see how accurate our model is. And we're gonna do that by taking the amount of correct predictions over the total predictions. You know, pretty makes sense and intuitive how like accurate was your model, right? But now we have precision and recall. So I think the best way to explain precision and recall is by these examples. So in the example of the fraud versus non-fraud in like a banking and finance perspective, precision is of the fraud cases, how many were actually fraud, right? And that of the predicted fraud cases, I should say. So our model predicted a ton of fraud, how much was actually fraud and how much was like false positives, like weren't really fraud or wasn't really fraud, but we marked it as that. So that's precision. And recall, or it's also called sensitivity, which I think is a better way and more intuitive way to remember it. But of all the actual fraud cases, how many did we detect? So this is now instead of saying looking at all the predicted cases and how many were actually fraud. Now we're looking at all the predicted cases and then how many did we not predict that were actually fraud, right? And this, I didn't want to jump into it by saying like, you know, true positive, false negative, false positive, true negative, because that's kind of hard to kind of digest your mind around. So I hope these examples help. But yeah, basically, recall is like the sensitivity of your model. And like I think this is really the best way to put it is of all the actual cases that we predicted, how many did we miss completely? Right? Because the first one we predicted them and they were just wrong, but there were some that just went under the radar that we marked as negative, but they were actually fraud, you know? And so that's the difference between them. Again, I don't want to spend too much time on it. So just get what you can from that. Then we have the F1 score, which is an even harder thing to wrap your head around, so I'm not going to spend too much time on it. But basically, it's like this harmonic mean of precision and recall. Um, Accuracy that is more sensitive or better to imbalanced data sets. So it's basically like a better accuracy score if your data set is imbalanced, right? And I wanted to draw something out for this really quickly. Like, for example, say our data set had 300 not fraud cases and 5 cases of fraud that we found, right? And let's say um our out of all these cases, let's say our model predicted all the not fraud cases correctly, but all the fraud it only got 3 out of the 5 ones for fraud right. So how accurate is our model then? Well, if we're gonna go off of just straight accuracy, that's 303 over 305. Our model's super accurate. Um, and so it's like, yay, okay, wow, that's like 99% accuracy. Let's ship it, right? No, because we're missing the real important stuff, the fraud. We need to fix our model. And so what the F1 score shows you through this algorithm, not algorithm, this equation down here is that it kind of balances this to where it'll be a more realistic representation. Um, and I think the score will probably end up being like something like zero point 0.6 or something in comparison to like 0.99%. Um, and so I think that that's probably the best way to explain that. Let me clear all this. All right, so that's what the F score is, or F1 score. And I have like that example right here. Imagine a data set with 5 fraud and 300 non-fraud, right? That's exactly what I said. Okay. Let me close this now. All right, and our next one, also part of model evaluation, how do we evaluate regression models, right? And so there's a couple ways to do it. A lot of them are pretty mathy, but I'll try to explain them as best as I can without showing you the math part. Excuse me, sorry. So we have mean absolute error. And this is basically intuitively how much was the average assumption off by. And like in our example, an example where you're predicting house prices, and then let's say our model was off by usually $20,000 up or down, doesn't really matter. That's why it's like the absolute error because the absolute values. So it's like up or down $20,000. That one's not really commonly used, but I would say that's the most interpretable when you're doing regression examples. This next one isn't as interpretable, but it gives you a better idea of how well your model is actually doing. For example, the mean squared error, this shows, or that's what I'm talking about, the mean squared error. Each value is squared before it's averaged. And like, what's the point of that, right? Well, the point of it is to penalize larger errors more than small ones. Obviously, if you square a smaller number, not much is going to happen. But when you square a larger number, and like say your model is off by a larger estimate, then it's really gonna show when it comes to the mean squared error, because your larger offputs are squared. And so that's usually I would say one of the main ones that you look at. And we had the next one I have up here is the root mean squared error, which is the same as a mean squared error, but then you square root it at the end. So it's kind of balancing off that interpretability with like, penalizing larger errors by squaring it back at the end. Um, but yeah, so it's a little bit more interpretable than mean squared, but not as interpretable as absolute. And then finally we have the R squared score, which basically it detects how much variance your model has between the target variables, and you basically use this score in correlation to what your actual data is, to really see how it's doing, right? And so those are the regression examples. And down here, I have the just unsupervised all kind of brought together. And these are even harder to try to explain, but I will do my best. First, we have the silhouette score, which measures how well separated the clusters are. Because if you guys remember from Machine Learning 101, unsupervised, you don't give it any labels. Instead, you just make the model cluster the stuff itself, and then from there, you kind of draw out. Like the insights from the data. But basically, the silhouette score measures how well separated the clusters are. The Davies-Bolden score or Bolden index measures the compactness and separation of these clusters. We have the explained variance ratio, and this is going to be for a topic called dimensionality reduction. Um, which we're going to get into in a future workshop when we go over unsupervised models more in depth. But basically, dimensionality reduction kind of if you the way I think about it intuitively is you squash down features, but you still keep how much they impact. But now that you squash them down, it's a lot easier to visualize from like a business perspective. You could kind of tell that it means that through dimensionality reduction. But it measures how much variance that each component retains after getting reducted. And then we have T-distributed, these are some big ones. T-distributed stochastic neighbor embeddings and uniform manifold approximation projections, which sounds scary. All it is visualization, right? They're shortened to TSNE and UMAP. And these are just important visualizations when you're clustering data. Here I have an example right here. This is TSNE and this is UMAP. As you can see, it color codes them, and it kind of shows you how the clusters look, like how you could visualize the data better that way, right? And then bottom left here, I have the math between the mean squared, root mean squared, and then the mean absolute error. And so you guys can check that out if you're interested. But yeah, that's how it's all done, right? Okay. And then finally, for model evaluation, I'm going to go over just a general model evaluation. I think it more relates to regression models, more so than like unsupervised, or sorry, supervised models more than unsupervised models, and I think especially regression models. But anyways, there's this idea behind data science and just machine learning in general called bias and variance, and then underfitting and overfitting. And so I'm going to kind of explain to you really quickly what that all means. So bias is the oversimplification error, and variance is the oversensitivity error, right? And so you might be thinking oversimplified and oversensitive to what? To the training data. right? So what bias does, a high bias means that you've oversimplified the training data, and you can see that here. The model doesn't really move much. It just is going in a straight line in comparison to high variance, which is you're being really sensitive to the training data. And so now you have like this really weird point by point. You want to get every training point right, right? And so these both have their trade-offs, right? A high variance in a real world scenario would be really low error, and a high bias in a real world scenario would also be, did I say really low? Really high error. Because basically, if you're mapping your models directly to the training set, when it sees new data, it's not going to be mocking a one-to-one with the training set, right? And so, it's going to be, there's going to be a lot of error there. And then high bias, obviously, it didn't even try to make the line. It didn't even try to make the model. It just gave us a line. And so, obviously, it's going to be pretty high error once we throw it into the real world. And it's also high error on the training set. Um, but anyways, that should give you guys an idea of what underfitting and overfitting is. If you just think about it a little bit, underfitting, this underfit the data and this overfit the data. That's all it really is. But they're these four terms I would say are pretty common when talking about or evaluating your model. So definitely just have them in the back of your head somewhere. Um, and there are many strategies to combat high bias versus high variance versus low bias, low variance, overfitting, stuff like that. There's a lot of strategies out there, and because of that, we can't cover them today, but we will in future workshops. And I'll talk about more about future workshops and stuff we have coming up at the end. But yeah, we just can't go over it today. There's a ton of stuff you can do. But yeah. And so now that we're done with evaluating our model, right? Now we're on step number 6, tuning or optimizing our model. And just put simply, even if your model performs well, it could always be improved somehow, right? With a bunch of fine-tuning techniques. And again, we're gonna talk about these techniques in future workshops because they differ model by model, so it's kind of hard to give you guys a general statement. But your models can be fine-tuned. You could adjust some hyperparameters to make things a little bit better. Um, and now we have part 7A and 7B. Now that you made your model and your model is great and it's what you want, there's two things that you can really do. You could either deploy your model in a real world setting, and then this is basically just putting it out there. In the example of our fraud versus non-fraud example, you would be putting it on like a banking app, and then we would track every user transaction and send alerts if we think one's fraud, right? So we're putting it in the real world. Um, and even this comes with a lot of difficulty because just because you made a model off your training data and it's really good on like our test set and our data, there's a lot of stuff that could happen over time that will make your model worse. There's this thing called like I think data drift where our model is used to these trends that were in the original data set, but then as time goes on and stuff changes, our data is gonna start like being a little bit different. And then so there's gonna be these new indicators for fraud. And so you just have to keep on keeping up with your deployed model and keeping up with stuff like that. And if you guys are more interested in model deployment, we could also host a workshop on that, but that's all we're really gonna talk about because we're not gonna be deploying models for the Datathon. But that is one thing you can do. Right. I would say the most important thing that you guys should really take after you're done with your model is visualizing the insights, right? So basically, this is like creating visualizations for like the model's performance. And this could be through many things. We've already kind of went through how to evaluate your model, and so visualizing it will just add that extra step when you're trying to explain it to people. So here I have confusion matrices, which is if you guys remember that table that I had with the FP, FN, TP, TN. I didn't really explain what that was, but FP and FN are false positive, false negative. TP, TN is true positive, true negative. Um, and then we can visualize the feature importance, the importance of every feature in your data set. And this is usually through like heat maps and stuff like that. But here I said, oh, permutation importance is like a important one. Measuring how much removing a feature affects the accuracy. Like for example, if we notice that this feature is really important, the best way to visualize that is taking it out of the data and then running the model again and seeing how much it declines in accuracy because of it, you know? Um, And then we have some general insights, right? We could do bar graphs, histograms, heat maps. And this is if you're just starting, I would really, try to do this stuff, especially if you're trying to find a job. This really shows that you know what you're doing and you know what you're talking about. Because anybody could like, make a model with some data, but if you're able to explain it afterwards, it's really impressive. And finally, the final step in the data science pipeline is finishing the job. So every data science project should end with key takeaways, actionable recommendations, and suggestions for like future improvements, right? Anyone could just gather data and throw it in a model, but it's up to you to really gather the insights and value from the data. And I think that's what kind of the whole point of what I'm trying to say today is that a lot of the actual steps of implementation and coding, a lot of them anyone could do, right? But it's up to you to really extract that knowledge from the data. And so that's kind of the most important part. You should have when you're done, so something to take away that's important from what you've learned, right? Something actionable, maybe a way to implement the model, maybe some steps that you can take to try to make action given the data. And then like some suggestions for future improvements, right? Your model is never going to be perfect, and you should know that, and you should understand why it's never going to be perfect, but also, say stuff that can be improved in the future. All right. And so that's it for the data science pipeline. Oops, I'm going a little ahead. Sorry. That's it for the data science pipeline. We have those 8 steps. I would definitely, if you're still learning, look back at this. I'm really gonna have to rush here, but I'm glad that we took our time there. And so now we're gonna talk about data science versus related fields. This is basically the data science pipeline visualize for you guys. First, we start with the business understanding, that business problem. Then we're going to collect data, clean the data, explore the data, and then we're going to throw it into a machine learning model. Then we're going to evaluate that model. And then after we evaluated the model, we either visualize or deploy it or both, right? And so we have these 5 categories that I've picked, and there's probably a couple more that I missed here, but I think these are the main ones that people probably will be interested in. So if you've seen these and like you don't, if you here, let me get you guys involved. If you guys have seen any of these and don't know what they really do, type one in the chat. I just want to see. Unless maybe you guys know everything about every single one of these, but I'd be surprised. Like business intelligence. ML ops. Do you guys really know what that stuff does? Thank you. I got some ones. I got some ones. Okay, thank you. Um, so we're gonna go through it pretty quickly today and explain what each of these kind of does in comparison to data science. So the first one is gonna be business intelligence slash data analyst, and what these guys do is they get the business understanding and then they visualize like the outcomes. Basically, their main focus isn't the machine learning side, but it's actually gathering as much insight as you can from the data, from the business perspective and kind of from the machine learning perspective. But the main focus is to try to extrapolate what you've learned from these settings and then bring it to like your stakeholders, your business, right? And so now we have data engineers, and they specialize in data collection, data cleaning, and exploration. Basically, they make these pipelines to try to get as much data as possible to the data scientists. And there's a lot of complication behind that because, there's a lot of messy data out there. I wish all data was stored neatly, but it's really not. And so they do go through a lot of work. And so these are like the 3 main steps I would say they do. And so data science uh, does these 4 things, right? They explore the given data, they make machine learning models, and then after they make the models, they evaluate them, and then they visualize their outcomes, right? And explain what they kind of got from the data set and all that information. And so that's an example of what data science scientists do. And machine learning engineers are kind of similar to data scientists, right? They're gonna make those machine learning models. They're gonna evaluate those machine learning models. But instead of visualizing them, machine learning engineers usually deploy these models into the real world. And so that's kind of, I would say, the key difference between machine learning engineer and data science. Um, and then we have machine learning ops or ML ops. This is kind of a newer field to me, but from what I've seen, they really focus heavily on the deployment of the models because especially if you're deploying a large model, there's a lot that goes into that. And so they really specialize in this area to try to get everything as streamlined as much as possible. And even they even do stuff like when your machine learning model is taking in new data, maybe they import that to some data set, and that's new data that maybe this machine learning model is constantly training on, stuff like that. So they basically take care of the deployment process and taking care of all the stuff around that. And so that's what I have here. But that being said, no matter what you're gonna have to understand all this, right? I don't think there's a single data engineer that doesn't understand the business side of what they're doing, right? Or maybe I don't think there's a single data engineer that doesn't understand what machine learning model their data is gonna get put into, right? If you're a data scientist, better believe you're gonna know how to clean data and even collect data and definitely understand it from the business perspective. And even deploy data, right? Even the data analysts, like they're gonna wanna understand how the data was cleaned and like how the model was evaluated to best visualize their outcomes, right? So all of these have a lot of overlap in them. This was just kind of a rough idea of what each one does, particularly, but everyone kind of does everything, if I'm being honest, right? Okay. And so now, this is probably what you guys have been waiting for, how to get started. So you've learned all this stuff about data science. You know what the pipeline is. You know how we go through things step by step. Now you want to know how to get started. Where do I start, right? So first things first, I don't know how many new people here are here, but you're gonna want to learn Python. As we go more into the future, the two main languages I'm seeing that are used for data science are Python and R, and now more and more it's just becoming just Python. So if you don't know how to code in Python already, just find an online course, familiarize yourself with it. It's a really intuitive language, thankfully, but I would definitely just learn Python if you haven't, right? Okay. And then I would say the recommended learning environments are going to be Google Colab or Jupyter Notebooks. Um, Basically, if you're familiar with like IDEs, these are a little bit different, but this is where data scientists kind of do most of their work. They don't usually do it in like a .py file. They do it in these things called .ipynb files, and those are called Jupyter Notebooks. They're not that confusing. Don't be intimidated by this. Once you get started, you'll understand what the difference between that and a normal environment is. But yeah, I just want to share that there. Right. And so these now are going to be the essential tools that you need. Or Python libraries is what they really are. They're not really tools, they're Python libraries. But you're going to use them as tools. Um, and so the first one is going to be pandas for data pre-processing. This is the one tool where I would say before you even get started with your first data science project that you watch a tutorial online for. I have a recommendation for a video here. It's called Learning Pandas for Data Analysis. Start here by Rob Mula. I think it's like a 22, 23-minute video. He covers the basics of what like data frames are, the group by function, how to merge data sets. Because basically you do all of your pre-processing and data management in these things called data frames a lot of the time, and that's all just a construct by pandas. So this is the one tool where I'm like, you should watch a tutorial before you start data science because, like I said earlier, you're going to spend most of your time data pre-processing, and so it's really important to know the tool. Um, and then we have data and model visualization tools. The two most popular ones are Matplot and Seaborn. I wouldn't stray outside of those. They need basically have everything that you need. And the deeper you go into them, the more you'll find that there's a lot of useful stuff in there. But this will help you visualize your data and like your model evaluations. Well, actually, no. Model evaluations is the next one. So all the machine learning and evaluation that you're going to get is going to be all from scikit-learn, right? Unless you're working with deep learning models, which then you'll be using PyTorch or TensorFlow. Scikit-learn is literally going to be the platform you need for all model evaluation and all um, machine learning, like machine learning models. But the code I had from earlier, for example, was from scikit-learn, and you saw it was literally 2 lines of code to make a model, right? They simplified everything like crazy, but there's a lot of depth to scikit-learn. There's like so many models on there, and like there's so many different metrics that they have. So these are like the four I would recommend if you're getting started. And honestly, this is all you need to be the best data science scientist possible. You don't need any other tools unless you're interested in deep learning, like I said, which then you'll look into like TensorFlow or PyTorch. But these are the only four you really need in data science. And so, a little bit more on how to get started. Where do I find high quality data? If you guys haven't made a Kaggle account already, definitely do so, especially if you registered for the Datathon. Um, it's going to be on Kaggle, so I would make sure to uh like have a Kaggle account. But basically, Kaggle is a Google owned company, and they just have a ton of data sets that people have already kind of cleaned for you. Not clean in the way that I explained today, but basically that they're all in a neat CSV format, and like the tables are like all have like they usually all have like feature names that are actually readable. A comparison to like if you go out there and find your own open data, like a lot of that stuff is so messy. And so Kaggle has like all the main data sets that you're going to want to get started. And I would stay with Kaggle for a while you're still learning. Um, and so for your first data science project, and I would really advise that you start this soon, this week, even if you're interested. Um, it's going to be the Titanic machine learning from disaster data set on Kaggle. This is like the number one starter data set, right? And don't kind of take that and be like, I want to be different. I think I'm better than everybody else. I can start with a different one. No, no, you're not. Start with this one. Trust me. This is like a great data set to get started. There's a lot of materials online to help you get started. And this will also teach you how to submit stuff on Kaggle, which is going to be really important for our upcoming Datathon. Um, but yeah, look into this. I have a really, really good thorough tutorial here where they're going to walk you line by line in code on YouTube. It's going to be called Beginner Data Science Portfolio Project Walkthrough, Kaggle Titanic by Ryan and Matt Data Science. This is the main one. Um, it's like I think it's gonna be like a hefty 2.5 hours long. But I'm not telling you to get it all done in one sitting. If you do, that's great. It's probably bad if you do though, because you're probably not retaining a lot of that information. But I would definitely work your way through that line by line. They do a pretty decent job of explaining themselves and what they're doing, but they also expose you to a lot of the scikit-learn tools that you're gonna need, the pandas tools that you're gonna need. Um, I think they do some pretty good visualizations towards the end as well. So it'll get you exposed to what a data scientist thinks like, right? And how you should think. And as well as the implementation, which is probably the most important part, or one of the most important parts. All right. So as I say here, follow the video and replicate it line by line. Don't like, I've done this mistake before. It's like you get to tutorial, and then you like get their starter code for some reason, or like they're finished and then you just follow the video looking line by line. Don't do that. Code line by line, especially if you're learning a lot of these new frameworks. Definitely do that. And I say here that the thought process behind it is a lot more important than the syntax slash code, right? The syntax slash code part will come a lot more naturally, a lot more faster than the actual thought process of thinking like a data scientist. So don't get all bogged down on the syntax. You'll learn it eventually, especially the more projects you do, but really understand how people think when they're looking at data science projects and like their perspectives on it, right? And then, so now that you've done that, assuming that you have, now it's time to start structuring your first solo data science project. And this is what separates you from all other data scientists. Oh, sorry. Uh, let me restart that. What separates you from all other data scientists is your domain knowledge. This past summer, actually, I reached out to a data scientist because I myself was kind of struggling on how to get started in the field, and I had this kind of close family friend who works in data science on the East Coast as a data science manager, actually, and he worked his way up. And I reached out to him, and I got on a phone call with him for like 45 minutes, and the one thing that I got away from it is that anybody can do data science. Anybody could write those 2 lines of code to make a model. Anybody could, you know, make a data set into train test validation, right? but only so many people are gonna understand what the data means, and only so many people are gonna know how to break the data down in the right way and the most optimized way for your model. So that this is why I'm saying the most important thing is the domain knowledge, right? And as you're getting started, I would say that you should start brainstorming what field you're kind of interested in, and that's what I'm gonna get into right here. It's the hardest part, which is a thing that I had a tough time with was picking the problem slash like data set slash data that I wanted to work with when I first started my own like solo project. Um, because you kind of if your goal is to get a job at the end of the day too, which it shouldn't be your main goal, but like obviously all of us want a job. The job market's cooked. If it's one of your goals, you're gonna wanna have like a data set or like a field in mind, a subfield in mind when you're creating your projects because like again, like I said, everybody could do stuff with data, but when if companies know that you're familiar with like the topics that they do, they're gonna want to pick you over somebody who just, did some data science project on something random. But so this is really the hardest part. And so I have some examples here to try to get you guys brainstorming on what might interest you. The first place, obvious one, healthcare, right? There's a lot of stuff you can do there. There's disease prediction. You could do stuff with personalizing medicine, etc. There's so much more stuff you could do. Like there's a lot of like sub areas in disease prediction. There's also stuff you could do like when it comes to optimizing like hospital systems and the fact that getting like patients in and out as optimal as in an optimal flow as possible. That's one example. But like healthcare is a big one. Business slash finance is a huge one. There's stuff you can do with risk management, fraud detection, like kind of what we were talking about today. And then algorithmic trading, if you guys are trying to get rich and trying to make a machine learning model that like predicts stocks or something, that's a lot of people find that fun. And so you might be interested in business slash finance. We have social media and digital marketing, right? We have recommendation systems. So if you want to work at a big company like Google and Netflix, anything that's part of FANG, a lot of the stuff they do is digital marketing, right? To try to get their brand out there, to get people hooked, basically. And so if you're interested in working at one of those companies or interested in recommending stuff to people, that's super cool. And there's also, but before I continue, there's a bunch of like sub examples here, and there's way more examples for every single field. I'm really giving you like broad fields to go into. There's a ton of subfields that you might be interested in. But anyways, continuing, we have supply chain, which is like you could do stuff like demand forecasting. This is basically where you're trying to help businesses be as optimal and save as much money as possible. And then there's all these other fields. There's sports slash entertainment, cybersecurity slash defense, energy slash environment, education slash research, etc. Before I continue, by the way, it hits 7 p.m. So if you gotta go, feel free to. You guys have a great rest of your day. The rest of this will be uploaded. I'm gonna stay a little bit over, just because I really want to get all this out. But if you have to go, I just want to let you guys know that now. But anyways, so kind of how I went picking my first project, which I'm still working on, by the way, because like there's so much to continue to work on when you're making your first data science project solo. Um, my thought process was I didn't really know which field to go into. I know that I like cars, so I was like, okay, automobile is cool. And then I also know I like the environment and like, I thought the idea of sustainability would be cool. And so I thought of this idea where I'm doing like a data science project based around electric vehicles and like more specifically I picked this topic of like the life cycle of electric vehicles versus non-electric versus like hybrid stuff like that. Um, and so like that's just an example of how I thought about it. And you want me to tell you guys how I thought about it and how I came up with that? Chat GPT, right? It's hard to get started. You don't have to just come up with this brilliant idea, the perfect idea. ChatGPT exists. These AI tools, chatbots out there exist already. Let them help you brainstorm. Um, and so if you guys are struggling with an idea, I would definitely just like start typing stuff into ChatGPT of what you're interested in and let it recommend you a ton. A lot of the ones that it's going to recommend to you are kind of like cliche, or some of them you might just not like. But some of them you might actually be interested in. So I would recommend that when you're trying to pick your first solo project. right? And some other tips that I have is don't be too niche. I pick electric vehicles. I didn't pick like, a specific brand or something. That'd be ridiculous. Because we, at the end of the day, we want to be hireable. These are gonna be projects that are one day probably put on our resume. So, don't be too niche. And then finally, most importantly, take it slow, learn as much as you can, and like stay consistent. If you can, spend like 1 hour a day working on it, that'd be amazing. And some days are going to be harder than others, of course. But if you just get that constant flow and like familiarity with like these data science topics and the data and like the syntax, you're gonna eventually pick that up in like weeks time. You're gonna just it's gonna be natural to you. So just take it slow and stay consistent and really understand that when you're first getting started, this is a learning process. We're not really fighting for an end goal here. We're fighting to get familiar with the stuff we're using. So, those are my two tips about that. And so I also want to say stick with Kaggle for now. Um, again, like I said, Kaggle has a bunch of clean data. And so, and there's a lot of ugly data out there. But if you want to, for your first data science project, if like the area that you're looking into, there's not a Kaggle data set for whichever reason, which that usually isn't the case. But if there isn't, there's a bunch of open source data sets out there. Some huge ones and some lifesavers for me have been like data.gov, which is all US data because the governments are supposed to share their data openly. All US government data, a lot of it is ugly and not clean and like in different file formats, so it's kind of weird. Um, but it helped me when I was trying to find like some niche stuff when I was first starting. But I would really stick for cat with Kaggle. There's no shame in going with Kaggle for now. But later on, you don't want to stick with Kaggle forever because once you start getting familiar with the stuff, you're probably going to want to start learning how to start cleaning data before you create like a whole data set or how to merge data sets. And so when you do that, you probably want to go check out other websites. But yeah, all right. And so that takes us to our closing. Um, and I'm going to close it here with one last slide. So thank you everybody, first of all, for sticking around so long. A lot of you are still saying, so I appreciate that. But kind of what we started with today. Hopefully you guys have a better understanding of what this really means now. Data science is a process of taking noisy data and extracting knowledge and insights that can lead to actions that a business or organization can take. And now that we've gone through the whole data science pipeline, which again I have right here, um, you should probably have a deeper understanding of what that really means, how that is done, and like how you can do that as well. Um, but that's kind of like the whole idea is taking this noisy data, which is basically unclean data, um, and cleaning it and trying to get insights out of it, right? And so, this is my last piece of personal advice. And that I wanted to kind of give you guys in this like super oversaturated market. I'm talking about like computer science, computer science in general. I would say that you need to stand out if you want to like get a job, and everybody knows that. But I really want to make it clear to you guys, especially a lot of the younger people that are watching the workshop right now. Start now before it's too late. Like a lot of this stuff is like good and it's good to keep it into the back of your mind, but it really doesn't mean anything if you don't start implementing, if you don't start actually trying to learn. Um, one thing that I strongly believe is that a lot of people are saying the job market is cooked and stuff, but those are like the same people that are like, going to CS thinking that they could get a six-figure job with a degree with no outside work. You have to put in a lot of work, and it's even more work with how oversaturated the market is than it should have been. But I'm letting you know now that you have the tools to start, get started now. And before you know it, you're gonna get those internships. They're gonna be like, "Wow, how'd you learn so much about like this specific field? Oh, wow, you're really familiar with these tools, right?" And so I'm telling you guys, I just want to say, just get started now. Don't procrastinate. Just, get started as soon as possible. And so that's it kind of for the closing. Now I'm going to talk about our workshop program. I'm not sure if you guys were here for the what was it? The GBM number 2 that we had past Wednesday. But we announced this, and this is a pretty big thing we have. You guys are obviously workshop goers, and so we have this huge workshop program next week, starting literally a week from today. And so I just want to share this with you guys. We're literally up until the Datathon, we're gonna be hosting a workshop every day, and we're working really hard to try to get these out to you guys. So I would definitely take advantage of them. Um, but I'm just gonna go over day by day here and what to expect from each one, in case you guys haven't seen these already. So a week from today, March 3rd, we have exploring your data. It says exploring you data. Now, exploring your data, which is basically we're gonna go over how to implement like a in-depth exploratory data analysis, which is basically just getting a bunch of insights from visualizing your data. And we're also going to go over a little bit of pre-processing, but mostly just getting as many insights you can as from the data, just like a EDA. That's what we're going to be doing, and that's what we're going to be showing you guys what to do and how to do it on March 3rd. And then fourth through sixth, you guys probably can tell that we're going to be going over each pillar of the Datathon. Again, if you're not interested in the Datathon, you don't have to show up and still learn. But that's what the point of these are. And basically, we're going to be walking you guys through some code on these different models, as well as telling you guys like some strategies um, for these specific types of models. A lot of the advice I gave today was general, and there was some specified advice, and that stuff was kind of quick. But each one of these days, we're really going to be going in depth on those types of models, and I feel like if you're more interested, you're going to learn a lot more from going to these workshops in particular. So I would just definitely check these out. We have one, the fourth, which is unsupervised or supervised models, which is going to be your classification and regression tasks. There's a lot to learn there. So you guys will hopefully learn a lot. We have March 5th, the unsupervised models is going to be like your clustering models, and stuff like that. We're going to talk about dimensionality reduction, and we're going to show you how to implement that stuff and how to evaluate these models. And then finally, March 6th, we're going to talk about vision models. These are usually a lot deeper, like neural networky models. And so we're going to show you guys the popular ones that are already out there, as well as how to kind of pre-process your data specifically for them, because they're a lot more different than like the non-vision data that we're working with now. And so we're going to go over a quick workshop of that day. And then finally, March 7th, we're going to go into how to win AI data. And assuming that you guys have been accepted into the Datathon at this point, this workshop is just basically how to pitch your model, how to show that you know what you're talking about, know what you're doing to your model, and how to do that correctly, and also like kind of give you the mindset as you're working through this data science pipeline, how to kind of keep track and make sure that you're really showing that you know what you're doing each step of the way, and then know how to, show that to a judge. And so that's what we're going to talk about March 7th. And March 8th, that Saturday, is AI X Data. That's our big datathon. If you guys haven't heard about it already, I hope you did because the submissions just closed. So if you didn't, it's too late, but it's fine. Honestly, it's just an event. Um, and it doesn't really mean anything in the big grand scheme of things. If anything, the workshops like these probably help you guys more. Well, it's a big event, but I'm just kind of saying this to say that if you don't get accepted or you didn't sign up, it's fine. Just don't let that stop you from going out and making a product on your own. Okay? And I think those are all the closing statements I have for you guys. Yeah, and so finally, thank you guys. I know I went way over what I promised, so sorry about that. But hopefully you guys learned something today. And that's gonna be calling it the end for this workshop. I'm gonna stay like 5 minutes after to answer some questions if people have some. But other than that, thank you guys so much. You guys have a great rest of your nights. And if you have any questions, feel free to stay back. Andrew, I see that you